Hello, and welcome to the Creo Parametric Advanced Assembly demonstration. In this brief demonstration, we will cover a few of the main topics in advanced assembly management, including the simplified representation tool, top-down design strategy, and variant design. We will also demonstrate how easy it is to create assembly process planning documentation using Creo Parametric. The model used in this demonstration is the Xmark Laser Z lawnmower. Xmark uses Creo Parametric in order to create the world's pioneer lawnmower. Creo Parametric provides different simplified representations to improve the ability of managing large assemblies. This is a unique function versus our competitors' capabilities. You can create simplified envelope parts to substitute for detailed design assemblies and improve assembly performance. And it provides different simplified representations to retrieve partial or full model information. The graphs represent the retrieval time and memory usage when working with the Laser Z mower within Creo Parametric. Let's now open a defined, simplified representation of the digital mower model. The preview function helps the user avoid mistakenly bringing a large model into the session. Let's switch to the combined views to review the model. The combined view can include orientation, a simplified representation, an exploded view, and/or information about layers. The on-demand simplified representation can interactively remove components in and out of memory when selected. Here the selected component is in the graphics representation mode. Notice that when we activate the part, it automatically turns it into a master representation. But once we cancel the change, it will go back to the graphics representation. During the product development process, an increase in top-down design methodology has been used in various industries. Creo Parametric provides a 6-stage top-down design solution for product assembly. Designers can use the Layout tool in Creo Parametric to plan the top-level requirements, define space allocation, and capture the key design intent. The second stage will create the initial product structure, which is the foundation of an efficient distribution of the design task. In this process, only the empty parts need to be created, but all the resulting product structure can be managed immediately in a product development system, such as PTC's Windchill PDM link. The third stage is to capture the design intent. Creo Parametric will use a unique solution, skeleton modeling, to capture the design parameter and control the object's interfaces. The fourth stage will be managing the independent relationships between various design objects. We'll take full advantage of the parametric and associativity functionality of Creo Parametric to manage efficiently independent or dependent objects to ensure our design intent. The fifth stage is to communicate the design intent. The top assembly designer can easily distribute design task and intent to individual groups by using Creo Parametric's skeleton modeling to copy and distribute geometry functions. It will ensure the efficiency and quality as well as reduce the design complexity. After all the 5 stages are completed, we will go to the 6th stage, which is the assembly stage. Let's simply go through the design process I mentioned above. We will start by creating a skeleton model. It includes all our design intents and many of the key parameters. You will see the design information such as the sketch, surface, and benchmark interface. In addition, Creo Parametric supports a unique skeleton model, which is the motion skeleton. The advantage of this model is that we can use it to easily and quickly validate the mechanism by inspecting the range of motion and interference. In a lawnmower, the front deck can move in the forward, backward, or up and down direction. We will focus on the deck height from the ground and the distance between the rear wheel and the deck. we need to make sure the distances are large enough to avoid a collision. Now, let's switch to the mechanism analysis module to analyze the kinematic of the motion skeleton. In this analysis, we can see the movement of the deck and the distance measurement. We are also shown a distance time graph chart of the deck movement. This makes it very easy to work with the motion skeleton in order to evaluate the design. The geometry information of the mower frame and deck is controlled by the skeleton model. Therefore, we can modify the geometry on the skeleton model and all the changes will be automatically propagated to the other related components. Let's change the length from 7.8 to 12 and increase the width of the deck case from 39.5 to 43. We will see the changes after regenerating the skeleton model. Let's go back to the assembly and switch to the top view to have a better view of the changes made. We just demonstrated how the digital prototype can be easily updated by adjusting the skeleton model. We will now demonstrate the advantages of reference management in a top-down design solution. Let's take a look at an example. We will need to adjust some simple settings before we use the reference management tool. Some of these settings are to not allow any geometry of an inactive assembly to be changed, and we can also set a specific color to reflect the reference information. We will need to assemble a part into the appropriate subassembly. Let's activate this subassembly first, and then insert the pedal model. Notice that the color of some components turn red, which means these components can be used as a reference when assembling. We can now easily add 3 constraints to assemble the pedal. By simply dragging the pedal, we can validate the constraints of the pedal. We can also use the reference viewer to trace and reference between parts. Reference Viewer will show the reference in a graph, which makes the review very easy. If needed, we can modify the range and types to get the reference we want. We will now take a look at the Creo Parametric variant design solution. Creo Parametric provides different methods to accomplish the assembly change, such as family table parts, copy model, etc. The first one is the exchange group, which provides functional and simplified exchange group types based on our needs. The second method is to interchange components and subassemblies. You can apply the change variant design by editing the program, such as to show or remove certain features or close and delete the parts. It is easy to create an automatic and intelligent design using Creo Parametric. If we want to change the model of the entire front deck, the system will remind us if we want to change the design since we already set the program control. Currently, the mower displayed is assembled with the 8593 assembly, which is the Ultra Cut 60 deck. Let's now choose a different model type, such as the 8594. Pay close attention because the geometry information has also been updated. We can see that we have a larger deck which corresponds to the Ultra Cut 72 model. In addition to changing the front deck, we will want to exchange the seat. We already have created the interchange group, therefore, all we need to do is open that file. The 3 seats can easily be interchanged by each other. Let's go back to the top assembly in order to replace the seat. Before we replace the seat, we'll preview the seat to make sure that it is the one we want to install. Even though we consider a lot of relationships between parts and subassemblies during the digital prototype development process, it's still very hard to imagine the real assembling process in the manufacturing process. However, Creo Parametric provides a specific tool to design and manage the assembly process. In every step, we can define the assembly, disassembly, lubrication, and other pertinent steps. We can also include other important information, such as the estimated time, cost of each step, and an exploded view of the process plan within Creo Parametric. Creo Parametric can also support the fabrication unit creation. Here are the 3 fabrication units in this process planning. Based on the assembly process, we can easily create the engineering drawing to document the process. On the corresponding drawing of the various assembly processes, we can easily view the parts involved using different colors and views. By designing the process planning documentation in Creo Parametric, the product manufacturing department can easily obtain reasonable process plans. The parallel process between design and scheduling will effectively reduce the defects after the product is manufactured. This concludes today's demonstration. We have demonstrated several important features and functions of the Creo Parametric Advanced Assembly. Capabilities demonstrated were using simplified representations to improve large assembly management ability, deploying the complete top-down design solution in order for high-quality design and effective collaboration to exist, quickly and efficiently customizing product variants according to a customer's unique requirements by interchanging the components with different methods, and rapidly and effectively creating the assembly process planning. Thank you for your time and attention.